Hi friends. So let's look at polynomials. Let's look at sample questions and solution from previous year's question papers. So first question, the zeros of polynomial 3x squared plus 11x minus 4 are. So they have been given options half comma minus 4, 1 by 4 minus 3, etc. etc. Those are the options you have. So we'll solve this quadratic polynomial using inspection, right? Find zeros of 3x squared plus 11x minus 4. To solve by inspection, you have to find two numbers whose product is 3 into minus 4 minus 12 and whose sum is plus 11. Okay, so minus 12 can be expressed as 12 into minus 1 or 3 into minus 4 or 6 into minus 2. But among all these combinations, only 12 into minus 1 is the right combination you have to choose, because adding 12 and minus 1 will give you 11. Okay, so the 3x squared plus 11x minus 4 equal to 0 implies 3x squared plus 12x minus 1x minus 4 equal to 0. So we have split it according to that. And then we have taken 3x common out, 3x into x plus 4 minus 1 into x plus 4 equal to 0, which implies 3x minus 1 into x plus 4 equal to 0, which implies x is equal to 1 by 3 or minus 4. So the option C is the right answer. Second question. In figure, graph of p of x is shown. Number of zeros of p of x are either 1, 2, 3 or 4. Okay. The answer is the curve cuts x-axis in three places. It cuts it at A, it cuts it at B, and it cuts it at C. So the number of zeros is equal to the number of roots is equal to 3, because the graph cuts the x-axis at three places. So C is the right answer. Graph of p of x cuts x-axis at 3 points and touches it at 2 points. So the number of zeros or roots of p of x is either 1, 2, 3 or 5. So even if it is touching or cutting, it is counted as a root. Okay. So if you look at the graph is cutting at A, B, C and touching at D and E. Okay. So if it cuts or touches, it doesn't matter. It is a root. So x-axis has 5 either cuts or touches. So p of x has 5 roots. So answer D is the correct answer. X minus 1 is a factor of p of x, which is x cube plus ax squared plus 2b, and a plus b equal to 4. This is given. Okay. So, they are asking us find the values of a comma b. They are saying x minus 1 is a factor of p of x. Remember, if x minus 1 is a factor of p of x, then 1 is a root. Okay. If x minus a in general is factor of p of x, then a is a root of p of x. So p of 1 must be 0. Okay. So substituting for x for 1 as 1, we get 1 cube plus a 1 squared plus 2b equal to 0. That implies a plus 2b equal to minus 1. But they have already given a plus b equal to 4, isn't it? So equation 2 minus equation 1, both on the LHS and the RHS, when you subtract, you get a plus 2b minus a plus b is equal to minus 1 minus 4. Okay. Simplifying, you will get a plus 2b minus a minus b equal to minus 5, which implies a cancels out, 2b minus b remains, b equal to minus 5. Substituting b is equal to minus 5 back in equation 1, you will get a plus minus 5 equal to 4. When you take minus 5 to the other side, you will get a equal to 9. So b equal to minus 5 and a is equal to 9. Therefore, b is the correct answer. Next question. One of the zeros of quadratic polynomial 3x x squared plus 3x plus k is 2. So one of the zeros is 2, which means if you substitute that value in this equation, you will get 0. Okay, that is why it is called 0, right? Value of k is what? So since 2 is one of the roots, you can substitute it. Since 2 is a root, you substitute it in the quadratic polynomial, you will get 0, which means 2 squared plus 3 into 2 plus k is equal to 0, which implies 2 squared is 4, 3 into 2 is 6, plus k is equal to 0, which implies k is equal to minus 10. So B is the correct answer. Okay. Alpha and beta are zeros of x squared minus 1. Then alpha plus beta equal to what? See, alpha plus beta are zeros, roots of the equation x squared minus 1. It has the x squared term. It doesn't have the x term, which means b is 0. Okay. Remember, our quadratic equation is of the form ax squared plus bx plus c is equal to 0. In our case, alpha plus beta, we know that it is minus b by a. The sum of the roots or sum of the zeros we know is minus b by a. But in our case, in x squared minus 1, there is no x term, which means the b term is 0. So minus 0 divided by a in our case is 1 because x squared is having a constant term of 1. So minus 0 by 1 equal to 0. So D is the correct answer. Alpha and beta are zeros of 4x squared minus 3x minus 7. Okay, they are the roots of 4x squared minus 3x minus 7. What is 1 over alpha plus 1 over beta? See, 1 over alpha plus 1 over beta, when you simplify, you take the LCM as alpha beta. The first one will become beta plus alpha. Okay, the second one alpha. So the numerator will be alpha beta divided by alpha into beta. Okay, so 1 over alpha, 1 over beta simplifies into numerator alpha plus beta divided by denominator alpha beta. Now, what is alpha plus beta? The sum of the roots. That we know as minus b by a. What is alpha beta? That is the product of the roots. That we know it as c by a. Okay, so we get minus b by a divided by c by a. So minus b by a multiplied by a by c. Because of the division, it will get inverted. A will cancel. The answer will be minus b by c. In our case, in 4x squared minus 3x minus 7, b is minus 3. Okay, but there is already a minus sign. Okay, you should not forget the signs. So minus sign is already there. B minus 3 you have substituted. C minus 7 you have substituted. Minus and minus will become plus, but there is a minus in the denominator. So plus divided by minus will be minus 3 by 7. So D minus 3 by 7 is the correct answer. Quadratic polynomial whose product of zeros is 5 and sum of zeros is equal to 8. Okay, the product is 5 and the sum is 8. And which of these is that polynomial? See, we know alpha beta is equal to 5, that is the product is 5, alpha plus beta is equal to 8. Okay, if we are given the sum and the product, we know that the quadratic polynomial is of the form k multiplied by in square brackets x squared minus alpha plus beta into x plus alpha beta. Okay, so you get k into x squared. Substituting for alpha plus beta, we get 8, and substituting for alpha beta, we get 5. So k into x squared minus 8x plus 5. So answer A, which is k into brackets x squared minus 8x plus 5 is the correct answer. If alpha and beta are zeros of x squared minus k plus 6x plus 2 into 2k minus 1, that is one fact. The second fact given is alpha plus beta is half of alpha beta. Okay, then k equal to what? See, we know that alpha plus beta is minus b by a. Okay, what is b in our case? It is minus k plus 6. Okay, so substitute for b, and what is a in our case? It is 1. Okay, so minus of minus becomes plus. So alpha plus beta gives you k plus 6. Correct. Alpha beta is c by a. What is c in our case? 2 times bracket 2k minus 1 divided by 1. So you will get equation 2 and 3. Okay, but there is a relationship given saying that alpha plus beta is equal to half alpha beta. So substitute 2 and 3 in equation 1, we get on the left hand side k plus 6 is equal to half of alpha beta. What is alpha beta? From equation 3 we are substituting, it is 2 times 2k minus 1. Okay, so half, that is 2 in the denominator and 2 will cancel. You will get k plus 6 is equal to 2k minus 1. Okay, you take the k to the other side and you bring 1 to this side, you will get k is equal to 7. So B is the correct answer. Quadratic polynomial, sum of whose zeros is minus 5, that is alpha plus beta is minus 5 and product alpha beta is 6. is which of these? Okay, we know that a quadratic polynomial whose sum of the roots is given and whose product of the roots is given is of the form k into x squared minus alpha plus beta x into alpha plus alpha beta. Given alpha plus beta is minus 5, which is the sum, and alpha beta, the product is 6, you just substitute it. Okay, you'll get k into minus and minus will get become plus 5x, and alpha beta, it will become 6. Take k as 1. Okay, k is a constant which can be any value, any integer or fraction value it can be. So if you take k is equal to 1, the polynomial we are looking for are is x squared plus 5x plus 6. Okay, so a is the correct answer. Note that when I'm writing, just to keep it short and to the point, I'm using shortcuts like QUAD dot is quadratic, POLY dot is polynomial. So all, and instead of zeros, I am writing it as Z subscript S. All these shortcuts are only for this video. When you are answering in the exam, you should not use any shortcuts and you should write complete words. Shortcuts are used here only to make it simple and compact, but that should not be used in the tests or examinations. If one zero of a polynomial p of x is equal to 6x squared 37x minus k minus 2 is reciprocal of another, find k. See, you are given a polynomial, that is a quadratic polynomial, 6x squared plus 37x minus k minus 2. Okay, they are saying one root is the reciprocal of other. So if you multiply the roots, you will get 1. Okay, so we know that alpha beta is c by a. What is c in our case? Minus bracket k minus 2. Okay, what is a in our case? 6, because the coefficient of x squared is 6. So alpha beta is equal to c by a, that is equal to minus k by 2 divided by 6, that is equation 1. But they've already given that beta is reciprocal of alpha. Okay, beta is equal to 1 upon alpha. So alpha into beta equal to 1. Okay, so alpha beta is, according to the equation 1, it is minus of k minus 2 by 6, and it is also 1 according to equation 2. So using 1 and 2, we can say that k minus 2 divided by 6 is equal to 1. Okay, simplifying, we get k equal to minus 4. Again, you have to use simplification tips when you are writing your exam. Okay, here I'm not doing it. I'm keeping it short, but you have to show all the steps. If the product of zeros of ax squared minus 6x minus 6 is 4, find the value of a, find the sum of zeros. Okay, so the roots product he is saying is 4. So whenever you are asking us about the product of the roots, you should immediately write down the formula alpha into beta is equal to c by a. So alpha beta is equal to c by a, which is 4. Product is 4. And what is c in our case? Minus 6. What is a in our case? A itself. Correct? So 4 is equal to minus 6 by a, which means cross multiplying, you will get a is equal to minus 6 by 4, that is equal to minus 3 by 2. Correct. Now alpha plus beta, we know sum of zeros alpha plus beta is minus b by a. What is b in our case? Minus 6. Correct. So minus of minus 6 divided by, we already know what a is, okay, which is minus 3 by 2. So we get minus of minus 6 divided by minus of 3 by 2, that is equal to minus 4. So the sum of zeros, that is the sum of roots, is minus 4. Find the ZS. ZS, again, I am using a shortcut. Please don't use it in the examination. Here I used it only for keeping it simple and short. Find ZS zeros of 90 squared minus 60 plus 1. Verify the relationship between zeros and coefficients. Okay. Let us solve it by inspection. Find two numbers such that their product is 9 into 1 and their sum is minus 6. Okay, so 9 can be expressed as 9 into 1, 3 into 3, minus 3 into minus 3. Okay, among these choices, we will take minus 3 and minus 3 because adding them gives us minus 6. Okay, so 9t squared minus 6t plus 1 equal to 0 can be written as 9t squared minus 3t plus 1 equal to 0. So taking 3t common out of the first two terms, you get 3t into 3t minus 1 into 3t minus 1 for the third and fourth terms is equal to 0. Now take out 3t minus 1 common, you get 3t minus 1 into 3t minus 1 is equal to 0. This means t equal to 1 by 3 and t is equal to 1 by 3. Both the roots have the same value, which is 1 over 3. Okay, so what is the relationship between the product zeros and coefficients? See, if you take the product of these two roots alpha beta, that is 1 by 3 into 1 by 3, you get 1 by 9. But check it with c by a. What is c by a? In our case, c is 1 and a is 9. So c by a is also 1 by 9. So alpha beta is equal to c by a. We have verified that. What is alpha plus beta? 1 by 3 by 1 by a plus 1 by 3. 3 is a LCM, it is common, no need for taking LCM, you'll get 2 by 3. Okay, and what is minus b by a? Okay, minus b is minus of minus 6 divided by 9, right? 3 2s are 6 and 3 3s are 9. So alpha b plus beta is also 2 by 3, minus b by a is also 2 by 3, hence verified. Okay. Find quadratic polynomial whose zeros are reciprocals. Reciprocals of zeros of polynomial ax squared plus bx plus c. See, you have a polynomial ax squared plus bx plus c, and let's say the roots of this polynomial are alpha and beta. What they are asking is find a quadratic polynomial whose zeros are reciprocals of that. So, if alpha beta are the roots of ax squared plus bx plus c, we know that alpha plus beta is minus b by a and alpha beta is equal to c by a. Correct? Now, let us say we have another set of two roots alpha dash beta dash, okay, of some quadratic polynomial. Then we have it in the form k multiplied by x squared minus alpha dash plus beta dash x plus alpha dash beta dash. Correct? Now they have given that we want a reciprocals. So alpha dash is equal to 1 by alpha and beta dash is equal to 1 by beta. Okay, there is a small correction in equation 1. It should be alpha dash into beta dash, not alpha beta. It should be alpha dash into beta dash. Okay. Now, given that alpha dash is 1 by alpha, beta dash is equal to 1 by beta, because they have given that the roots of the other quadratic polynomial are reciprocals. Okay, substituting in the equation 1, we get it is k into x squared minus 1 over alpha plus 1 over beta into x plus 1 over alpha beta. Okay, now taking the LCM we get that is k into bracket open x squared minus alpha plus beta divided by alpha beta into x plus 1 over alpha beta. Okay, but we already know alpha plus beta is minus b by a and alpha beta is c by a. So substituting that in this equation, we get k into x squared minus b by a divided by c by a into x plus 1 upon c by a. Okay. Finally, simplifying it, we'll get it as k into x squared plus b by c into x and a by c. Now take k, which can be any constant, as c and multiply it throughout. Okay. When we multiply it throughout, we get k as c, we get cx squared, b by c, c and c will cancel, you get bx, and a by c, c and c will cancel, you get a. So cx squared plus bx plus a is the quadratic polynomial whose roots are reciprocals of the roots of ax squared plus bx plus c. Find the zeros of quadratic polynomial 7y squared minus 11 by 3y minus 2 by 3 and verify zeros and coefficients. See, whenever you have some denominator in some of the terms like this, it is convenient to multiply throughout by a constant factor. Because see, we want to find the roots of 7y squared minus 11 by 3y minus 2 by 3 equal to 0, isn't it? So if we multiply the LHS and RHS by 3, we get 7 3s are 21y squared. 11 by 3, 3 and 3 will cancel, you'll get minus 11 by 2 by 3, 3 and 3 will cancel, you get minus 2 is equal to 0. RHS also you multiply by 3. 0 into 3, you'll get 0, right? This is a more easier and convenient equation to solve instead of having fractions. So friends, whenever you have fractions, it is better to multiply left hand side and right hand side so that that fraction part is gone, and then solve the equation. The roots will be the same. Okay. Now to solve by inspection, we have to find two numbers whose product is minus 42. Okay, and whose sum is minus 11. Okay, so 42 can be you can see the working in the margin. Okay, 42 can be expressed as 7 6s are 42, 21 2s are 42, or 14 3s are 42. But we'll take 14 and 3 minus 14 and positive 3 as the choice, because minus 14 plus 3 will give us minus 11. Okay. So solving by inspection, we can split the middle term minus 11 as minus 14 and plus 3. So this implies 21y squared minus 14y plus 3y minus 2 is equal to 0. Taking 7y common out of the first two terms, we get 7y into 3y minus 2 plus 1 into 3y minus 2 equal to 0. Taking 3y minus 2 common, we get 7y plus 1 into 3y minus 2 is equal to 0. That implies y is equal to minus 1 by 7 or 2 by 3. So these are the two roots. Okay. And once you get the two roots, you can verify the relationship between the roots and the coefficients. If you take the product, alpha beta is equal to minus 1 by 7 into 2 by 3, that is minus 2 by 21. Correct? What is C by A in our case? What is C in our case? Minus 2. What is A in our case? 21. So C by A is minus 2 by 21. So we have verified that alpha into beta is equal to C by A. Alpha plus beta. Okay. Minus 1 by 7 plus 2 by 3. What is the LCM of the denominator 7 and 3? It is 21. So to convert the first term to the denominator 21, you are multiplying it by 3 and 3. Okay, both in the numerator and denominator. So numerator becomes minus 3. And to convert the 2 by 3 into the appropriate denominator, you are multiplying both denominator and numerator by 7. So numerator becomes 2 sevens are 14, right? So 14 minus 3 is 11, 11 by 21. Okay, what is minus b by a in our case? Minus b by a is minus of minus 14, that is 14. Okay, divided by, sorry, minus of minus 11, right? In our case, b is minus of minus 11. And what is the denominator? A is 21. So minus of minus 11 is 11 by 21. So we have verified that alpha plus beta is 11 by 21, and minus b by a is also 11 by 21. Find the quadratic polynomial. Sum and product of zeros are minus 1 and 20 respectively. So sum is minus 1 and product is minus 20, because respectively is used. Also find the zeros. Okay. So we have the format. Whenever the sum and product are given, the polynomial, quadratic polynomial is of the form k into x squared minus alpha plus beta into x plus alpha beta. Given that alpha plus beta, the sum is minus 1 and alpha beta is minus 20, and we are going to take k is equal to 1. Okay, because there is no reason to take anything else. So when we do that, we get x squared plus x, because minus of minus 1 gives you plus 1, and alpha beta minus 20 is equal to 0. Now we need to solve this by inspection. Okay. Now we need to find two numbers whose product is 1 into minus 20 minus 20 and whose sum is 1. Okay. So 20 can be expressed. You can see the margin 20 into 1, 5 minus 5 into 4, 5 into minus 4. But we are going to take 5 into minus 4 as a combination, because that is what will give us the 1 when added as we need. So the term x squared plus x minus 20 can be written as x squared plus 5x minus 4x minus 20 equal to 0. Taking x common, you'll get x into x minus 5. Taking minus 4 common, you'll get minus 4 into x plus 5. take x plus 5 common, you will get x plus 5 into x minus 4 equal to 0, which means x is equal to minus 5 or plus 4. Okay, so this is the two roots, minus 5 or plus 4. What is alpha plus beta? It is minus 5 plus 4 minus 1. What is minus b by a? In our case, b is 1, a is also 1. So minus b by a is minus 1. So alpha plus beta is minus 1, b minus b by a is minus 1, verified. What is alpha into beta? Minus 20. What is c by a? C is minus 20, a is 1. So minus 20, c by a is also minus 20. Therefore, verified. Find zeros of quadratic polynomial 3x squared minus 2 and verify zeros and coefficients. Note that even here the x term is not there, which means in our case the b is 0. Okay, it can be written as 3x squared plus 0x minus 2 equal to 0, or 3x squared minus 2 equal to 0, which implies you take the 2 to that side and send the 3 down, you will get x squared is equal to 2 by 3, or x is equal to plus or minus square root of 2 by 3. What is square root of 2 by 3? Square root of 2 in the numerator and square root of 3 in the denominator. What is alpha plus beta? Alpha plus beta is square root of 2 by 3 and plus minus square root of 2 by 3, because the two roots are plus or minus square root of 2 by square root of 3. Okay, so denominators are the same and answer you will get it as 0. And what is minus b by a? In our case, b is 0. So minus of 0 by 3, you'll get 0. So we have verified alpha plus beta is equal to minus b by a. What is the product? Alpha into beta. It is root 2 by root 3 into minus root 2 by root 3. So root 2 into minus root 2, you'll get minus 2. And in the denominator, root 3 into root 3, you will get 3. What is c by a in our case? It is minus 2 by 3. So alpha beta is equal to c by a. Verified. Quadratic polynomial 2x squared minus 3x plus 1 has zeros alpha beta. Form a quadratic polynomial whose zeros are 3 alpha and 3 beta. See, there is a quadratic polynomial given to you, 2x squared minus 3x plus 1, and it will have some roots. They are asking you to form a quadratic polynomial whose zeros are 3 times alpha and 3 times beta. Okay, so 2x squared plus minus 3x plus 1 solved by inspection. Okay, easy. 2 ones are 2, and if you minus 2 into minus 1, you will get minus 3 as the sum and 2 as the product, right? So 2x squared minus 2x minus x plus 1, you can write it as that, equal to 0. 2x you take common, you will get x minus 1. Minus 1 you take common, again you will get x minus 1. So 2x minus 1 into x minus 1 is equal to 0, which means x is either half or 1. Okay, so your two roots, alpha is half and beta is 1. These are the two roots. Now form a quadratic polynomial whose zeros are 3 alpha and 3 beta. Okay, so when you do 3 alpha and 3 beta, that is of the form k into x squared minus 3 alpha into plus 3 beta into x plus 3 alpha into 3 beta. Okay, now substitute for alpha and beta. K into x squared minus of 3 into half plus 3 into 1 into x plus 3 multiplied by half multiplied by 3 multiplied by 1. Okay, simplifying, we get k into x squared minus 3 by 2 plus 3 into x plus 9 by 2. Okay, and taking the LCM for 3 by 2 and 3, we'll get 2 as the LCM. So 3 plus 6 by 2 into x plus 9 by 2 will get. Now take k as 2 so that you can cancel out the 2 in the denominator and multiply it across. So you will get the, taking k as 2, you will get the final answer as 2x squared minus 9x plus 9. So this is the quadratic polynomial whose roots are 3 times the root of the values that you formed. Alpha beta are zeros of x squared plus 6x plus 9. Form a poly whose zeros are minus alpha and minus beta. Okay, so first find out the roots. X squared plus 6x plus 9, by inspection you can put it as x squared plus 3x plus 3x plus 9. Okay, 6x is written as 3x plus 3x because 3x plus 3x will give you 6x and 3 by multiplied by 3 will give you 9. Okay, So take out x common, x into x plus 3, and take out 3 common. For the next two terms, you'll get again x plus 3. So x plus 3 into x plus 3 is equal to 0, which implies x is equal to minus 3 comma minus 3. So there are two roots, but both the values are same, minus 3. So alpha is also minus 3, beta is also minus 3. Now you want to form a quadratic polynomial whose roots are minus alpha and minus beta. So what is minus of minus 3? Plus 3, right? Correct? What is the, you substitute that, okay? So k of k into x squared minus alpha minus beta, because those are the roots we want, into x plus minus alpha into minus beta. Substituting, what you will get, right? Minus alpha is plus 3, minus beta is also plus 3, and minus alpha again 3, 3. You substitute it like that. You'll get k into x squared minus 3 plus 3, 6, that is minus 6x plus 3 into 3, which is 9. So taking k as 1, you'll get x squared minus 6x plus 9. Okay. If one zero of a quadratic polynomial, one of the zeros of quadratic polynomial 4x squared minus 8kx plus 8x minus 9 is negative of other, okay, then find the zeros of kx squared plus 3kx plus 2. So this is a two-part problem. One part they are asking you to find what is k, okay, right? And second part they are asking you to, once you found out the k, you get a polynomial kx squared plus 3kx plus 2. They are asking you to find the zeros or roots of that polynomial. See, if one zero of quadratic polynomial, this is negative of other, when you add those two, you get a zero, isn't it? So when you consider the sum of the, you know, sum of the roots alpha plus beta, you get minus b by a, but it's already given that b is equal to minus of alpha. So alpha plus beta equal to 0. Okay, so alpha plus beta is minus b by a. In our case, what is b? It is the x has minus 8k and 8. Okay, you have to take both. Please don't forget. See here, x minus 8k x is there and 8 is there. Both have x in them. So you have to take minus of bracket minus 8k plus 8 divided by 4. That is, when you bring the minus sign inside, you get 8k minus 8, 8k minus 8 by 4. That is 2k minus 2. But given that alpha beta is plus beta equal to 0, because beta is negative alpha, right? Because they have given one zero is negative of the other, which means 2k minus 2 is equal to 0, which gives you k equal to 1. Okay, once you get k is equal to 1, the zeros of kx squared plus 3kx plus 2, we substitute for k equal to 1, we get x squared plus 3x plus 2. You can solve this by inspection. You can split 3x as 2x plus x, okay, and you will get x plus 1 into x plus 2 is equal to 0. So either x is equal to minus 1 or it is minus 2. Okay. While playing in the garden, Samaira saw a honeycomb made by honeybees to store honey. Its shape is as shown in the graph. Based on that, see, you can answer comprehension type questions. You just have to keep your mind calm and listen to the question. See, this question has nothing to do with the honeycomb. It is just extra information. Mainly, you have to look at the graph which represents the honeycomb. Okay. The graph is cutting the x-axis at 7, 0, minus 7, 0, and the bottommost point has y minus 50. Okay, how many zeros are there? Obviously, if it cuts the x-axis at two places, there will be two zeros, isn't it? And what are those zeros? It is minus 7 and positive 7, because that is where it is cutting the x-axis. Okay, these are the two answers. The third answer, he is asking, if zeros of x squared plus a plus 1 into x plus b are 2 comma minus 3, determine the values of a comma b. Okay, see, a comma b, you know that the relationship between the roots and the coefficients. If you add the coefficient alpha plus beta, you get minus b by a. What are your two roots? 2 and minus 3. What is minus b by a? In our case, b is a plus 1. What is a? It is 1. So we are getting 2 plus minus 3 is equal to minus of bracket a plus 1 divided by 1, which implies minus 1 is equal to minus a minus 1, which implies a is equal to 0. Okay, and we also know that alpha beta is equal to c by a. What is c in our case? B. What is a in our case? 1. Right? There, and what is the product of our root 2 into minus 3, which implies b is equal to minus 6. Okay, so the value of a is 0 and b is minus 6. That is the answer for the third part. Okay, next question. Square of difference of the zeros. Okay, square of difference of zeros. That is, if alpha and beta are the roots or zeros, alpha minus beta is the difference. They are asking square of this. So square of alpha minus beta, that is alpha minus beta whole squared of x squared plus px plus 45 is 144. Find the value of p. Okay. Given that alpha minus beta whole squared is 144. Okay. Again, we know that alpha plus beta is minus b by a. What is minus b by a in our case? It is minus p by 1. So alpha plus beta is minus p. What is alpha beta? Alpha into beta is c by a, that is 45 by 1, that is 45. So we have two equations. One equation is alpha plus beta is minus p, and second equation is alpha beta is equal to 45. Now, 144 is equal to alpha minus beta whole squared. That is equal to alpha squared plus beta squared minus 2 alpha beta. You remember this formula, right? A plus b, a minus b whole squared is equal to a squared minus 2ab plus b squared. Okay. Now, this can be written as alpha squared plus beta squared plus 2 alpha beta minus 4 alpha beta, right? So, minus 2 alpha beta can be written as plus 2 alpha beta minus 4 alpha beta. Would you agree? And accumulating alpha squared plus beta squared plus 2 alpha beta, that can be written as alpha plus beta whole squared minus 4 alpha beta. Agreed? Okay. Now, substituting, we know that 144 is equal to alpha plus beta is minus p whole squared. And 4 alpha beta is minus 4 into, substitute for alpha beta, you'll get 45, which is p squared minus 45 into 4 is 180. Okay, which implies p, if you bring 180 to the other side, you'll get p squared is equal to 324. Therefore, p is equal to plus or minus square root of 324, which means it is plus or minus 18. Okay, thanks friends.